Hello everyone, can you all hear me? Just bear with me a second. We're not starting just yet. Just kind of bear with me. Hopefully you can hear me. Just bear with me because I believe someone has changed the password on the account that I'm meant to be streaming from. So I can't get onto it right now. So just bear with me, you know, just a slight technical difficulty because I believe someone, a lot of people use this account and stream from it. So I think someone has changed the password, which is really nice, which is really fun, isn't it? Really not stressful at all. Just bear with me just like a hot minute while I try and fix this. Give me 1 second. Thank you all. See you soon. I'm muted. That won't help, will it? Hello, everyone. Hello. So basically, I still can't get in. Fun. So I can't type in the chat. I can still read the chat. Like I can see it. It's on my second monitor. It's there. I just can't type in the chat. So bear that in mind. But hello, everyone. Hello. How are we all doing today? How are we feeling? Hopefully good. I also can't have the chat where I normally have it, like next to my camera. So if I look all the way over here, it's because I'm looking at chat. So bear that in mind as well. Cool. Okie dokie, guys. All of you having loads of good conversations already without me having prompting. That's good. Good. Year 10, year 11. So yeah, these are for mainly GCSE, but I mean, it won't hurt. If I mean, I've seen a couple of like year 13s, maybe year 12s. It's not going to hurt if you come around. We're going to do cosine rule and sine rule later, both of which are in, like, they're in the year level syllabus. So I mean, it's not as if it's bad to practice extra maths, I suppose. Cool. So, who here, I think you've already had discussion, but we'll have it again, why not? Who here is here for the first time? Who has been to any of the Magic live streams? So me on Mondays, there's Fliss on Tuesdays, and there's Enketia on Thursdays. So who here has been to any others, and who here is here for the first time? Let's have a look. Your first time, you're all new? Fun. So hopefully it'll be enjoyable. All we're going to do today is practice a bit of maths. Fun times. Now, a lot of you'll probably be on half term currently. You'll be having your mocks probably when you go back. And a lot of my students that I teach are all having mocks when they go back, which is kind of spooky. So hopefully this will help with those. So we're going to do quite a lot today, hopefully. We're going to start very soon. There's a lot to get through. We're going to try and quickly recap pretty much the entirety of trigonometry. So we're going to do Pythagoras' theorem, can never say it right. We're going to do SohCahToa. We are going to do the cosine rule, and we're going to do the sine rule. So all four, which is not all of trigonometry. There is some other little bits and pieces. There's things like exact trig. Not going to do that. There's also the area of any triangle. Also not going to do that one. But we're going to do the vast majority of it. So hopefully we'll get quite a lot done. So this session will last an hour. So we're already 10 minutes in, so it's going to last until 6 o'clock, essentially. So I'm going to be here live in front of all you guys until 6. So we're going to get in with it, we'll do some maths, and then last 5 minutes we're going to have a bit of a chat, just to decompress, de-stress, all that good stuff. For first maths, I went to study schools on Thursday. How'd you find it? I think I popped in at some point in Ketia's stream on Thursday. I think it was good, wasn't it? It's about positivity, which is quite nice. I've done doing higher or foundation. This is both. So SohCahToa and Pythagoras, they are both they go up to grade 5. Well, they can go higher than that, but the earliest they kind of go is grade 5. So they're going to be right at the end of the foundation paper. Then we do cosine rule and sine rule. They are just the higher paper. They're about grade 7. So when we do that, you can kind of switch off, relax for a bit until we go, maybe come back to it at the end. So foundation is just the first half of it, essentially. Then higher is going to be the second half. But higher, if you do higher, then obviously, as you probably know, SohCahToa and Pythagoras is going to be on your paper. So that all of the stream is for higher students. The first half of the stream, is for foundation students. Does that all make sense? But it won't harm, seeing there's going to be doing things like rearranging equations, using sine, cos and tan, finding missing angles, and that's quite useful for foundation students just to see. You don't have to do the exact math that we're doing, but it's quite handy to see all the same, I suppose, just for a bit of exposure to mathematics, I guess. Right then, are we all ready to get started? We're all ready to go. Do we all have our scientific calculators? Either that one or one like that. I'm double wielding today. Do we all have our scientific calculators with us in our hands? Cool. Possibly also a bit of paper, maybe a pen, pencil, if you're feeling that way inclined. So you can do a bit of working on the side as well. So what I'm going to do is I'm going to put on a question. You're going to have a bit of a go on it, and then we're going to talk it through together. Cool. Let's get started then. So first thing we're going to look at is kind of the easiest of all of them. You may not find it easiest, but I think categorically, kind of objectively, a little bit easier than the others, which is Pythagoras' theorem. I think it might have an apostrophe after that S that I've missed off, but well, it's not a spelling test, it's math paper, so I'm not going to lose any marks for spelling it wrong. But there we are. So that's going to be the first thing we're going to do, which is this one. So we want to calculate the length of AC. So can we all see that question? Are the numbers clear enough? Can we all see it? Make it big if we need, but hopefully we can all see that. Is it good? Is it in frame? Is it viewable? Yeah, feel free to have a go. Use a calculator for this because those numbers are a bit awkward. Don't have to use a calculator, could be non-calculator, but they're a bit awkward at them numbers, so you can use one. It's good, thank you, Evan. Grand. Cool. Perfect. Someone's typed in a good equation in the chat. Perfect. It is indeed. You can put answers in the chat if you like, Harry. That'd be good. Obviously, if you're still doing it, try not to look at the chat because I think you might get a bit spoiled, you know. If you look at the chat, then you're going to see the answer where you got it, and that's like, oh, drats, been spoiled, like a spoiler. Yeah, type in the chat once you've got it. Then you can see if you're right, so you don't like forget what you've got or anything like that. Okay, so I'll give you all one more brief moment, and then I shall go through it. Yes, you are. And you can use a calculator. This technically could be non-calculator because the numbers aren't that bad, but I don't want to do 4.8 squared on my head, in my head, so I'm going to use a calculator. So I can't be a hypocrite, can I? If I can use one, you can use one. But technically it could be, but it's too late in the day. Monday afternoon, doing that without a calculator? Not for me. No, thank you. No, thank you. Right. Okie dokie then. Let's go through it then. So, as we should all hopefully know, Pythagoras' theorem is as follows. Oops, daisy. Is as follows. A squared plus b squared equals c squared. And I'm just realising that'll be why my password didn't work. My caps lock was on. That was fun, isn't it? You can tell I'm tired? I can. Right. So we've got a squared plus b squared equals c squared. So out of all these sides, we've got this side ab, this side BC and this side like AC, which one is going to be this one? Because this one's the one that matters. So out of all these three sides, which one is going to be C squared? Yeah, no jokes, isn't it? Classic. I was going to go around, I was going to be really upset later with the people who run the accounts because it got changed without my notice because I had caps lock on. Maybe I should have checked that beforehand. I'm glad I noticed before I went mental because I would sound like a right Karen, wouldn't I? So I'm glad I didn't do that. And yes, you're absolutely right, Harry. It is indeed AC. So the hypotenuse is always C here. So it's always the one that's opposite the right angle. So this C is always this length that's opposite the right angle. So we need to leave C as it is. Don't know that one yet. So let's put all the other numbers in. We've got A squared. These ones, doesn't matter. Make them whichever one you want. Don't bother me. I'm going to choose A as this one and B as that one. But you get the same answer if you do it differently. It's just C that matters. C you have to get in the right spot. Others, irrelevant. Doesn't matter. So then we've got 4.8 squared plus 3.6 squared equals C squared. Okie dokie. Then I'm going to type these in, see what these are. So we've got 4.8 squared, which is 23.04. And then 3.6 squared, 12.96, okie dokie, that's equal to C squared. And then what I'm going to do is I am going to add these up, 12.96 plus 23.04, that's going to get me 36 equals C squared. Then to get C on its own, you need to get rid of this squared, you just square root it. So square root that, you get C equals 6. Technically also minus 6, but you can't have a negative length, so you get rid of that one. But there we are. Cool. Do we have any questions about Pythagoras theorem? Does it all make sense? How are you all feeling about that first one? Feeling good? I'll have a little sip of water. Feeling good? Hopefully. Yeah? Good. Grand. So yeah, and it will be easy for everyone because this is like grade 5 kind of stuff here. So it's not easy, like right at the top of end of foundation paper. So, but I don't. So what paper is people doing in the chat? Maybe you don't know yet, but are we doing higher or foundation paper? People in the chat. Does it always have to be in a right angle triangle? Yes, it does. It does indeed. So there's two separate, distinctive sets of rules. So we've got the rules for right angle triangles. We've got the rules for non-right angle triangles. So that's a good thing to go through, actually. Thank you for jogging my memory. So we've got a right angle triangle and we have got a non-right angle triangle. Let's just use that one, for example. So right angle triangles have 3 rules. Non-right angle triangles have 3 rules. 1, 2, 3. Right angle triangles, you have Pythagoras' theorem, and that's this one that we've just done. A squared is B squared plus A squared plus B squared equals C squared. And then we've got SohCahToa, which we're going to do next. SohCahToa. And then we've got the area formula, which is a half base height. So those 3, those are for right angle triangles only. So if you see a right angle triangle, it's probably going to be one of those 3 things. Pythagoras, SohCahToa, half base heights. Okay, and then non-right angle triangles, which are more common on that, the most common thing on the higher paper. Obviously you don't get them on foundation paper, non-right angle triangles, not for rules like this. So all these 3 rules here are all higher only, but you can get either on the higher paper. These ones are more common. Oh, you can't see it anyway. Let me shuffle it over. These ones are more common, but you can get these ones as well. Normally you won't get these ones outright on the higher paper. They'll be embedded in another question, like the infamous 3-circle question from last year that everyone, that nobody liked. That was a hidden SohCahToa question, I believe, or a hidden Pythagoras. No, higher is just like top set. So higher paper gets is grades like 1 through 9, and foundation paper is like 1 through 5. So it's like capped. So yeah, GCSE. They don't have tiers at A level. A level's just A level. Cool. And then we have the 3 for non-right angle triangles. That's the cosine rule, the sine rule, and the area of any triangle formula, which is a half AB sine C. There you have it. Now, if you're in year 11, you're in luck because you're going to get all these in your exams next year. So that finicky cosine rule question, that cosine rule formula you normally have to learn, given it. how handy. But normally if you're in year 10 or below, you'll have to learn all these for your exams. But there we are. Cool then. Does that hopefully that answered your question? So right angle triangles is just these three. Non-right angle triangles is all these three. Grand. Moving on then. So that's Pythagoras. So we'll maybe come back to that at the end. I'm going to do kind of a bit of a poll to what one we want to do first. We're going to knock them all out. We're going to do all four of them and then sweep around back again at the end if we have time. So let me move this, shuffle it back over. Let's progress. SohCahToa. Right then. This is the SohCahToa question. So work out the value of x. So we've got this triangle here. So the difference between Pythagoras and SohCahToa is that Pythagoras, you have two sides, want a third side. SohCahToa, you have an angle and a side, you want to find another side, or two sides, you want to find an angle. That's the difference. So SohCahToa always uses an angle, Pythagoras does not use an angle. That's the difference. Is it confirmed I'll have a formula sheet for this year 11? Yes, it is. Well, yes. Well, you know the government. You know what they're like, right? They could do a U-turn on it. That's very possible. But at this point of time, yes, we have an equation sheet for both physics and maths. It isn't confirmed yet whether it will be the same one as last year. That they haven't confirmed. But that's what I've been using last year's in tests and stuff and in when I've been teaching. So you can assume that they will be like the same as last year, but we don't know that for certain, right? But yeah, so you should get all your physics equations and your maths ones too. So if you Google what it was last year, it'll be the same one for this year, hopefully. And yes, this math lesson is...
I don't know about that.
Okay, Google. So yes, this lesson's every Monday. So I have a Monday slot from 5 to 6, doing maths, GCSE maths. And then Fliss, who's doing coding, she does Python, I think. I think she might do other languages as well at some points, but it's Python with Fliss on Tuesdays. And then Enketia does like study skills and how to like organize your time, how to think positively and all that good stuff on Thursdays at 5. So all at 5, I'm on Monday, Fliss is Tuesday, Enketia is Thursday. Good question. Thank you very much. Grand then. So how are we all doing with this one? I've seen one answer in the chat, I believe. How's everyone else doing? How are we all feeling about SohCahToa? This one's trickier than Pythagoras. This one is trickier. Hi, Keela. How are you doing? I'm doing good. Thank you very much. So how are we all doing with SohCahToa? You have a couple more minutes in case you're still thinking about it. And I'll go through it. Okay, you got 2 different answers in the chat. Ooh. See if anyone else is going to come in with a third. See if anyone agrees or has a different suggestion. Till 6. Roller till 6. Yeah, till 6. But if you join late or you need to leave early, they're all recorded and put on YouTube afterwards. So I've got 2 already up from last week and the week before on factorising linear and quadratic equations. So they're already up. So they're all recorded and posted on my tutor's YouTube channel. So if you do wish to watch it back, if you need to leave, I don't know, get some tea or something, feel free, and then you can watch it back on YouTube's later. Okay, let's go through it. So let's see what we've got here. So I've got a right-angled triangle. So then let's go through it. So first thing you need to do with SohCahToa is label the sides. So with SohCahToa, you've got 3 different types of side. You've got the hypotenuse, which is spelt like that, hypotenuse. You've got the opposite, and you've got the adjacent. Okay, so the way I order it is hypotenuse is the one opposite the right angle, always, or the longest side, either or. So this one is the hypotenuse. I then do the opposite side. So opposite is the one that's opposite the angle they've given you. We've already done the opposite to the right angle, hypotenuse. So the opposite to the other angle they've given you, whatever that may be, that's going to, or wherever that may be, that's going to be O. Then the one that's left, that's A. That's how I've labelled it. Then what I do is I write out those letters at the side. I've got H, I've got O, and I've got A. And then I put a tick next to whichever letters have something written on them. Could be an X, could be a length, whatever it may be, but it has something written on it. So H has nothing on it, as we can see, completely blank line other than my H. So that's got nothing on it. O has X on it, so that does, and A has 11 on it. So that does too. So I'm using O and A. Then I'm going to call on my acronym, which is SohCahToa. I'm going to look for a trio that has O and A in it. And that will be that one, which means that we use the letter T, which is tan. So then we get tan X. That's always the equation for tan, is opposite over adjacent. Always the equation, X being the angle you've been given, over the opposite over adjacent. Okay, then what we do is we get tan of the angle, which is tan of 42, equals opposite, which is X, over adjacent, which is 11. And then we get X on it. Oop, couldn't even see it. Shuffle that up there. Then to get X on its own, X is currently being divided by 11. Do the opposite of that. We're going to times it by 11. So we're going to do 11 times tan 42. That's going to equal X. Let me type that into my calculator. See what we get. 11 tan 42. And that is 9.9. So well done, Harry. I think you got it first. Very well done. Cool. Let's see. I've been seeing in the chat whirring as I've gone. Yeah, that's okay. If you got the wrong answer, I mean, no one who knows who you are anyway. All I can see is like a Kermit with some random letters, you know? No one knows who you are. It's always good to have a go, isn't it? Always good to have a go. At least, you know, you're benefiting. If you did the sine rule, would you also get the mark? I mean, yeah. But you won't be able to use a sine rule in this case. We don't have enough things for it, Khalida. Because we don't have... So for the sine rule, you need pairs. So you need a side as an angle and then a length another angle that's missing. And we don't have another angle, but we're trying to find a side. So we don't have enough information for the sine rule in this case. So you could, if you had enough information, you could definitely use a sine rule. But we don't have enough information for that. Does that make sense, Khalida? So yeah, you could. In certain questions, just not this one. Cool. Any other questions before we move on? Any other questions before we move on? We do the sine rule next, actually. So quite apt that we talked about it just then. We do the sine rule next. Does anybody have any questions? Are we all making sense? Or am I making sense? Hopefully. Great. You understand? What don't you understand about it? And then what is it in particular? Go through it again if you'd like. Just really briefly. We could also actually swing back into a question at the end as well on SohCahToa. To 11 and 42. So you see, is it why we have to times them or how we have to times them? Does that make sense? I hope that question makes sense. So which one is it? Is it y? Because y, I don't know, might as well answer both, hadn't I? So y is because we've got 11 down here and we have to do the opposite, inverse operations. So because we've got 11 on the bottom of the fraction and x on the top, we want to get x on its own, right? We want x equals something because we're trying to find out what x is. So what we need to do is free x from this current prism that it's in with this 11 underneath it, right? So to move this 11, we have to do the opposite to what the 11 is doing to the x. Currently the 11 is being divided, that line there, so we have to times it, do the opposite. So then we do 11 times 1042, then that makes x kind of drop down to be the only thing in the formula. Then we get x equals the rest of it. There we have it. That's the answer. Does that make sense? Hopefully. If it's the rearranging bit we don't like, we do a lot more rearranging later, so we'll do the other ones as well. It says a lot of rearranging. Yeah, no problem. Good question. It is tricky, rearranging equations. It's not the easiest thing in the world. Cool. Let's move on then. Let's do the sine rule. I like the sine rule. The sine rule's the easier of the higher ones. I like the sine rule. So, this is, some of you are asking anyway, so actually, good question. SohCahToa, that's about grade 5-ish. You can get it on the higher paper, but it's normally just a question just like that. That would be like, I don't know, second to last question on the foundation paper, maybe third to last question, depending on which exam board you did. AQA would be the last question, and Excel might be like the second or third to last question. OCR, don't know, I'm assuming somewhere near the end of a foundation paper. Higher, they wouldn't be asked that on its own. It'd be embedded in another question. It'd be trickier. Anyway, good question. Moving on then. So this is the part of the equation sheet related to this part of the topic. So the one that you're going to get this year, so if in year 11, this is what you're going to see for the non-right angled section of the equation sheets. So you're going to get the sine rule, which is that guy there, cosine rule, which is that guy there, that awkward thing, and then area of a triangle. So currently we are going to do this bit. Yeah, and I don't think anyone likes the cosine rule very much. It's tricky, because look at the state of it. It's such a long formula. And it's just not nice to work with. It's not an easy one to manoeuvre. You could also learn 2 versions of it. I don't bother learning 2 versions of it, but it's just a bit of a faff to deal with. So you're not learning, not liking the cosine rule. No one particularly likes the cosine rule either. Grand idea. Let's do the sine rule first. That's the easiest one. Then we can deal with the cosine rule later. Cool. So then, this is the sine rule question. So, work out the value of x. Give your answer to 1 decimal place. Okie dokie then. So, thing I was saying earlier, the sine rule is when you've got pairs. Actually, let me write out the sine rule so that you have it. It's a over sine A equals b over sine b. So if you're in year 11, you're going to get it anyway. And if you're in year 10, plenty of time to learn it. I'll give it to you. So yeah, sine rule works on pairs. So for sine, you have to have 1 full pair, which would be that pair there, and 1 half pair, which would be that pair there. I'll explain that in slightly more detail in a second. So let you have a go at it first. Cool. Do you have any questions while you're working it out? Leader to 1 decimal place, it said, but I mean, so you lose a mark in exams, so be careful. Always make sure you're reading how many decimal places they want it to, because they're finicky with it. They'll dock your mark. They're rather rude like that. That's okay. Everyone makes that same mistake, don't worry. I've seen many people do very, very good work in their papers and then lose silly marks because they've forgotten to round it. They're very finicky fiends, are the markers of these exam papers. They're very strict with if they've told you how many places they wanted it to, and they're very strict with it. Okay, what is A and B in the question? So, I'll start going through it. I'll start looking at the equation, so then everyone else has a couple more seconds if they want to have a go at the question. So, this equation, it's the lowercase letters in both the sine rule, the cosine rule, and the area of any triangle formula. The lowercase letters are the sides. Okay, lowercase letters are the sides. Doesn't matter which side you make which. Just obviously you want to make sure that that it's the sides that you have, right? And you don't want to make one of them C if you don't. You don't want to make this one A because you don't have that one. Does that make sense? It doesn't matter which one you make which, as long as it's sides that you have. And then the capital letters are the angles, which I think makes sense because it's with the sine and the cos in the cosine rule. That's like an angly thing, the trigonometry things. So lowercase letters, they are the side lengths. Uppercase letters, they are the angles. And you want to make sure that lowercase b the side is opposite uppercase b the angle. Lowercase a the side, opposite uppercase a the angle. And now technically the formula also had lowercase c sine capital C, but I never used that one. Because C's look too similar, lowercase and uppercase, and it just makes it a bit confusing. So I never bother. I just get rid of it. You only ever need 2 anyway. So I just scrap that one. I get rid of it. I cancel it. Good question. Cleda. Oh, not Cleda. A man. Cleda said something else. Professional. Yeah, it's easy to do. The way to get better at that is to just do past papers. That's all you ever need to do. Past papers. Then you get used to, because the more you make the mistake, the more frustrated you get with yourself. So the easier it becomes to spot it. Because I used to be awful with it too. With negative numbers, awful. Right? I forgot about negatives so many times. Hundreds of times, thousands of times even. So now I know I'm very careful with negatives. I put brackets in even when the poly doesn't need brackets, because I'm very nervous about my negatives and I know I'll slip up on them. So the more maths you do, the more papers you do, the more you notice where you're making these silly mistakes. So the more you know to look for them. You don't want to be upset with yourself later, essentially. So that's my top tip. Just do paper after paper after paper, because you will then see where the silly marks you lose every time, like mine with negatives. People lose marks with like fractions, with like rounding correctly, and you get frustrated with yourself and you remember the frustration, so then you learn to check it in your exam. Let's see what else we've got. I'll calculate into degrees mode, so you may have it in radians for some parts of maths and for if you did like add maths or something. So it depends on what calculator you have. I've got two. Just to help hand, Aman, is it the FX83 GTX or is it the FX85 GT Plus? Because it happens to be either of those. Let's have a look. What did you do for A levels? I did chemistry, physics, and maths. I did about 2 months of biology and about 3 months of further maths. Dropped both of them. That's what I did, because I resat all of my maths year 1 in year 2. So I had a busy year 2. FX83 GTX. Oh, I've got that one. Grand. So what you do is you go on to, let me remember now. Yeah. So you press shift and then setup, which is like that one. So shift, like the top left button, and then setup, which is next to the on button. And then you press number 2, which is angle units. Then you press number 1, which is degree. And I'll change it for you. Radians is for circles, but you don't need to know that GCSE. And then the other one, gradients, I think I've never used that one. Probably stats, I don't know. I've never used it. So, well, let's go through this question and answer all your questions. So we're going to have a bit of a time at the end to chat anyway. So store all these questions and in your noggins, and I will come back to them. Or maybe copy them and paste them later. I don't know. Let's go through this one. So then, first thing I'm going to do is I'm going to label this triangle. So we have A and B. I have 2 sides with something written on them. Let's make that one, I don't know, that one A, that one B. Doesn't matter, either or. Going to get the same answer. Then capital A is the angle opposite that length. That's going to be capital A. And then capital B is going to be the angle opposite that one. That one's going to be capital B. Then it's just a case of putting the stuff into the formula. So then I'm going to get x over sine of 38 is equal to, my face is going to get in the way, let me shuffle it over, is equal to 13 over sine 100. Okay, and then I'm going to rearrange this equation in a very similar way to the last time actually. I'm going to want to get x on its own, so what I need to do there is get rid of this divide sign by timesing it. So I'm going to times this up there, essentially. So I'm going to do x is equal to 13 over sine 100 times sine 38. You could put that up there, do 13 sine 38, but I think this is a bit, I don't know, not really simpler, but easier to digest in one bit. And all you do, type that in. So you get, let me type that in, 13 over sine 100 times sine 38. And that gives me 8.1. Technically 8.127067597 to 10 dp, or to 10 sig figs, but that's what they wanted one of ways, so I'm going to give it. So 8.1 centimetres. Cool. Okie dokie then. How was that one for everyone? Did that all make sense? You can't see a lot of it. Let me shuffle it over again so you can see all the working in one bit. There we are. How did we find that? How did we like it? Good. good. Glad we liked it. I like the sine rule. Yeah, the sine rule's good. Yeah, it is quite difficult. Man, it's not. This is grade 7. This one here. It's not easy by any means. The sine rule kind of averages, as is the cosine rule, about grade 7. So it is like pretty midway through the higher paper. It's really tough. Cool. Okie dokie. Actually, man, that needs to do a practice. Bring that up again at the end so I can talk through where to get good practice things from. I did sine 38 times 13. That should have worked. Then divide it by sine 100. That should have worked. Let me have a look. 13 sine 38. Did you divide by sine 100? You're right, I did get 8 for that one. But then divide it by sine 100, you get 8.127. Blah, 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 blah. So I think you just forgot to divide it by sine 100, Harry. Because that is correct. Sine 38 times 13 is 8. You should divide it by sine 100. And for this bit here. There we are. Yeah, there you go. That'll do it. Cool then. Okie dokie then. Let's move on. Let's do the cosine rule. And then we can do another question on a topic of our choosing. So let me swipe through all these. The cosine rule. Okie dokie then. Cosine rule is the awkward second cousin of the Pythagoras theorem. They're very similar at the formulas. So it's a squared. Oop, that's my highlighter. A squared equals b squared plus c squared minus 2bc cos a. So this is just Pythagoras theorem, just with a instead of c. Just swap the letters around. Still the same theorem, just different letters in different orders. And then with this addition. This addition just comes in whenever it's a non-right angle triangle, such as this one. So that's the formula. You label it in the same way that you label any other, like you label the sine rule. But be careful with this one, there's only one angle. So I wonder which letter that angle is going to have, and therefore wonder what letter the opposite side to that's going to be. So yeah, I'll leave that there. So have a go at it. If you get it, if you're really stuck, then let me know. We can go through it because I think people unanimously rather don't like the cosine rule. But let you guys have a look go first. While I drink my coffee in a can. How do you do 3D trig and Pythagoras? Oh, that is yeah, you're right. That is tricky. That's a completely different ball game to this. Completely different. So the actual Pythagoras and SohCahToa bit is no different. It's just having to conceptualize it in 3D space. People find tricky. Some top tips for that one. We don't do any today, so this is like just the bare bones of trigonometry. That is a part of it. You are right, but not a bit we're going to do today. So what I recommend for that is bringing different coloured pens into the exam and drawing over the lines that you think are going to be in the triangle, or the lines that you've got, and trying to form triangles with them. That's one bit of advice. I've been really like, I don't know, coloured pens that you can rub out on something. But yeah, I'll bring up where to find extra exam questions and things to practice with at the end. So don't worry, we'll talk about that later. Okie dokie. Got some good answers in the chat. Got some good answers. So let's have a look. We've got 42. Gosh, time flies so quickly, doesn't it? Time just flies. Right, let's go through it then. So then, let's have a look. So this A, we've only got one angle, so therefore this 100 is the angle we've got. That one must be A. Let's label that. This means that this one must be lowercase a. We've then got B and C, like with Pythagoras, doesn't matter. This one can be B or C, this can be B or C, doesn't matter. Let's call this one B, this one C. Okay, doesn't matter. If you've chosen the opposite way, so you're going to get the same answer. Okay, then all you need to do is type it all in. So a squared, that's just x squared in this case, let's put it down here. X squared is equal to 13 squared plus 10 squared minus 2 times 13 times 10 times cos 100. Okay then what I'd recommend doing is typing these in pieces. just for, I don't know, just to make sure you double check. If you type in a long string of numbers, it's harder for you to spot mistakes because obviously the first bit you type in goes on your calculator screen. So I would type them in this bit first, then this bit. Obviously it doesn't matter. You can type it all in one go if you like, but just to kind of save yourself typing a number in wrong, or to, I don't know, reduce the possibility of you doing that, I would type them in separately. So 13 squared plus 10 squared, that's going to be 269. Some quick maths on my part. Take away 2 times 13 times 10, which is, what is that, 26, 260? That I don't trust myself with. My mental maths, shocking. Oh, it is. Need to trust myself more. 260 cos 100. I would always also leave this minus in limbo. I'd never treat it with this 2 here, because then you have to change it to a plus and people forget to do that. Again, fun with signs. I've made the mistake many a time in my day, so trying to teach other people to not make it. So leave that sign in limbo and just follow it down. No matter what numbers you get here and here, just keep that sign where it is. And that's then x squared. And then type this in one go. So we've got 269. Take away 260 times cos 100. And I'm getting for that x squared equals 314.15. Then I'm going to get rid of this squared by square rooting it. And I am going to get 17.7. So you're all right. Yeah, look at that. And there we have it. That is the cosine rule. Obviously, the cosine rule gets a lot harder than that. It's a relatively nice cosine rule question, but it's kind of a good introduction to it. So how are you all feeling about the cosine rule? How are we feeling? Feeling good? Feeling better maybe than we were? Hopefully, if we got it right, that's a good sign. Rather good sign. Feeling good? Good. Good, good, good. How's everyone else feeling? Good, good. It is difficult. You are right, it is difficult. So cosine rule always comes up like 2/3 of the way near the paper. It's never easy. It always comes up rather like right near the end of the paper. First time seeing it? Oh wow. Are you in year 11 or are you in year 10? Maybe they teach it at the end in your school, because it's tricky. So some schools leave the tricky stuff to the end, so they cover it like just like fresh for the exam. That possibly maybe what's happened. Or you're doing foundation paper and then it's not in it. What would we do if we need to find an angle? That is a good question. Let's do one of those actually, because we've got kind of enough time to do like one more question, and that is kind of the toughest alternate to the other ones. All the other ones we've kind of skipped past all the other bits, but I think that's the toughest of them all. Find an angle with the cosine rule. Year 11, maybe you just haven't done it yet. Maybe that's the case. Maybe you just do it at the end in your school, which, you know, it makes sense. Do all the tricky stuff at the end, then it's like freshest for when you sit the exam. It does make sense, I suppose. But anyway, let's do a cosine rule question where you need to find the angle, because those ones are tough, much like this one. So, work out the value of x. Give your answer to 3 significant figures. So we've got a squared plus, a squared, if I can get the formula right. A squared equals b squared plus c squared minus 2bc cosine a. So let you have a go at it. It's labelled and done in the exact same way, just the rearrangement is more awkward. There is another equation you can learn, but I don't know it. I never bothered to learn it. I don't like learning alternate equations. I don't like having to cram more things into my head than I have to already have in my head. I've already got way too many things in my head to learn a separate equation, so I never bothered. But you can do if you like. If you Googled it, it'll come up. Maybe honest with the question. Last question I think we've done.
Got it. I'll stop.
Okay, Google. She's piping up a lot today. This question and last question, I think we've done.
Sorry, I don't understand,
weeks.
but I found something related. Do you want to know why am I always packing in my dreams?
Oh. Okay, Google, stop. That was weird. Some schools teach it at weird times, because trigonometry, it's not a massive topic. There's only 3 bits in it, apart from 3D trig, but you might have done that already. So it's not like the biggest topic in the world, so they might just be leaving it for the end, which is normal. But if And it's not that bad to teach yourself, actually, trigonometry. There's some topics that are really hard to teach yourself, and I recommend getting some other people to help, like teachers. But this topic's not too bad, actually. It's just putting numbers into an equation and rearranging it. But the rearrangement's like always the same. So once you practice it enough times, it'll go in the skull, the brain, eventually. So I'll let you guys continue having a go at this one. You have mocks next Monday. Oh, good luck. Best of luck. I know people have got loads of mocks coming, like starting soon. My brother's also in year 11, my little brother, that he was here. I told him to come, but I don't think he's actually coming or not. I don't think he's actually going to be here. Told him to come, but he's, I don't know, that's a year 11 boy for you, I guess. Yeah, it's stereotypical, I don't know. But, yeah, he has mocks when he goes back. He's off school this week and next week, so he has mocks when he goes back after half term, after Halloween. Fun. So good luck to everyone that does have mocks. Best of luck to everyone. There we are. Don't worry, MK. So actually, I might answer that now while you're all working on this one. I haven't had the answers yet. So I have submitted lesson plans like in advance. So my tutor had to approve them all. So I can't take requests, unfortunately. Wish I could, but unfortunately I had to have them all like approved and stuff. So I will get up actually. I'll get up on the telephone. What we're going to be doing the next couple of weeks, because that's on here. And just so if you did wish to come, you know, no pressure, but it's rather good. I think I quite like these sessions because I run them. So next week we're gonna do this. So we're gonna do like 2 weeks of displaying data, which is all like the data part of it. So we're gonna do scatter graphs and pie charts next week. Week after that we're gonna do averages and box plots and cumulative frequency graphs. That's the week after that. And then week after that, week 7, we're going to do ratio. Week after that, straight line graphs and inequalities on graphs. Week 9, angles in parallel lines and circle theorems. And week 10, finishing off with the tricky one, simultaneous equations. Both grade 5 and grade 9. Grade 9. So we're going to do those the next coming weeks. Hopefully that's okay. But there we are. Yeah, so Samuel he works on my tutor, as do I. So he has got a nice little, I forgot what it's called, like a survey. Yeah, let's go with that. A survey in the chat. So you can just tell them what you like about these sessions and what you don't like. Because obviously, it costs them money to run these. So if you wanted to make sure if it's worthwhile, if you're enjoying them, if you'd like to see more of them, what you'd like to see, that sort of stuff, just to say whether you enjoy them or not, or how we could improve. I'm well open to improvements. So yeah, feel free to fill in that form if you'd like. There is a chance to win a gift card. Wow! Imagine how many sweets you can buy with 20 quid Amazon voucher. I guess not many. It's Amazon. I never really buy sweets on Amazon. I don't know. Don't normally shop at Amazon. Don't know what they have. But I'm guessing a lot of things. So yeah. If you have the time, feel free to fill it in. So how are we all getting on? Did anyone manage to do this? Or are we all stuck? No answers through. Yeah, it is tricky. It's not the easiest thing in the world. How are we all getting on? You're stuck? That's fair enough. It is tough. I'll see if anyone else comes back. You got it? What did you get? What was it? Let's see. No answer? That's okay. You can go through it. Yeah, it's tough. The rearrangement on this one's it's probably the hardest rearrangement there is on the syllabus, on the math syllabus. It is tricky. That's why people learn a second formula, an entirely separate formula for it. But I don't like the extra formula. I think there's too much to learn already. But no, let's go through it then. So, a squared equals b squared plus c. A squared equals b squared plus c squared minus 2bc cos a. So, first things first, we still only have one angle, so that one's going to be capital A. In this case, it's going to be the one that we're trying to find. X, that's the only one we have anything written on, which means that 20 has to be lowercase a. Okie dokie then. Then, let's just start filling it in. So we've got a squared, that's 20 squared, equals b squared. Let's call this b again. B and c again, don't matter, same thing. So b squared is 15 squared plus c squared, that's 16 squared, minus 2 times 15 times 16 times cosine of x. Right. So the approach you should kind of always take with really tricky rearrangements is just focus in on parts that are going to make your life easier, right? So certain bits of this we can do straight away, certain bits of it we need to wait for later. Like it's fine, right? Rearranging all this at this current stage right now, mess, right? It's going to lead nowhere. So let's deal with the bits we can do first. Let's do all these squareds. Let's times these things together. Let's do the bits we can definitely do. So 20 squared, 400, is equal to 15 squared, which is what, 225, I think? I don't know, I don't trust myself enough for that. 15 squared, oh, it is 225. Perfect, plus 16 squared, that I don't know. 256 minus 2 times 15 times 16. Remember that minus stays in limbo. Don't group it with the 2, just leave it as it is. 480 cos x. And then from there, deal with the other bits we can do right off the bat, which is this bit here. Let's do that bit. So we've got 400 equals 225 plus 256. 481 equals minus 480 cos x. Now be very careful, don't be tempted to subtract these. They choose numbers that look very nice and subtractable on purpose, right? Don't do it, don't fall into the trap. Because this one is times by cos x. We don't know what that is, right? We have no idea what that guy is, so we can't subtract it yet because this is technically kind of like being 480 minus 480x, right? Different families, can't subtract. So what I'm going to do instead is, I know that I want this cos x to be positive, because a negative trig, how do I deal with that? Don't know, right? So I'm going to want this to be positive eventually, so I'm going to add this over there. Let's do that. So 480 cos x, just take the whole thing with me, grab all this, take it over there, and then it's now added to this 400, which was there already, equals 481. Okay. Are we following so far? I don't want to get to the end and I've lost everyone at this point. So are we following still? Does it all make sense? Are we following? Do we need a go over? Or are we following? Yeah, good. Thank you, Keela. Everyone else following? Hoops do. Carry on? Cool. Okie dokie. Then, so now we've got to this point, let's take this 400, because currently we want x on its own, so we kind of want this bit on its own here. So we're going to take this over there, subtract, so then we're going to do 480 cos x equals 481, take away 400, it's going to be 81, right? Okay, and then we want cos x on its own. So we're going to whittle this away, so we want cos x on its own, then we want x on its own. So keep whittling away, making it smaller and smaller and smaller until it's just x on its own, which then we've got the question solved. So what we're going to do then is, if we recall, 480 cos x is just 480 times cos x. So we're going to just divide this 480 down here. Then we've got cos x equals 81 divided by 480. So you could type that in, but it looks like it's going to be a mess, so I'm going to leave it at that for now. You could type it in, get it simplified, or get it as a decimal, but I'm going to leave it as is. And then from here, if you're ever left with cos, sine, or tan of an angle, and you want the angle, you must inverse. That's what inversing is for. So if you look on your calculator, above where it says sine, cos, and tan, you should see in like yellow writing, like sine -1, cos -1, tan -1. And that is how you get rid of the trig functions. Because essentially, it's kind of like divide, but for the trig functions, because you can't divide a trig function because they don't exist without an angle. They need an angle to exist, right? They can't just, they're nothing without an angle. So if we divide just cos down, we can't do that because there's no angle there because they've gotten rid of it. We've left it up here. So what we do instead is we inverse it, which essentially does kind of divide it, just in a trigonometric way, essentially. So what we're going to do then is x equals whatever trig function we've got up here. Just write it down here with a -1. Then whatever we've got on the other side all ends up in the bracket. And then if we type that in, let's see what we get. So inverse cos, I'm going to take these off actually, Not hearing anything anyway. Let's take that out. Cos minus 1 of 81 over 480. And I have gotten x equals 80.2. I think it was to 1 decimal place. 3 significant figures, which is the same thing in this case. How nice. Actually, 0.3. Silly me. Can't round. Whoopsie-daisy, whoopsie-daisy, whoopsie-daisy. There we go. 80.3. It's an 8 after the 2. Cool. And there we have it. That is the final answer. So well done. Well done. Kermit with a handgun. You got it right. Well done. Very well done. How is everyone else feeling? I know, it was a tricky one. It was really tricky. But that rearrangement is always the same, right? There's only 2 ways you can have it. You can have it missing a side. That side will always be A, right? You can't have any other side missing. It's too complicated. That side will always be A, right? Or you could be missing an angle. And if you're missing an angle, it's always this rearrangement. So if we don't like the rearrangement, all we need to do is keep going, keep doing it over and over and over and over and over again, and eventually it will stick. That's the joy of practicing maths. The only way you can get better is through a repeated practice. The only way to improve. Okay, how are we all feeling? We feeling good? Gone over time by a little bit, but made it so much easier. Oh, I thank you. I hope so. That's nice. Thank you very much. If you don't understand anything, I know it is really tricky. It's really tough. This question is like 7.5, right? It's kind of where it's up there. It's like mid-range grade 7. It is tricky, right? If you don't like trigonometry, so how I recommend if you don't understand a topic, here would be my stratagem, right? What I would do is YouTube, very handy, right? Search topic on YouTube, because if you don't understand one person explaining it, there's going to be hundreds, thousands of people on YouTube explaining the same topics, but in slightly different ways. So one of those people should hopefully click, right? So if you don't like the sine rule, just search in sine rule GCSE. There'll be loads of people on YouTube going through different questions, so you can see loads of stuff. Next thing I would recommend is then just having a practice, going through loads of questions on it. You can get questions from places like Maths Uni, they're rather good. MME, or Maths Made Easy, they're also rather good. Save My Exams, kind of pricey, but still, they're pretty good. PMT, also rather good. So there's a load of different, physics and maths tutor, there's loads and loads of different places you can get questions from. I would just, steal all their questions and go through them. So once you know a topic you don't like, write it down and just keep going. So the way you should revise maths is, you might have heard the saying before, you shouldn't revise maths until you get it right. You should revise it until you can't get it wrong. And that's the thing for maths, isn't it? Because it comes up in so many different contexts, so many different ways. Your brain should be kind of tuned to always, okay, if I see a question, if I see a triangle, it's a non-right angled one, that is either cosine rule, sine rule, area of any triangle. I know all those 3, I know how to deal with them. I'm confident. Right. So does anybody, before we finish up for today, have any questions about anything? I don't mind. The room is open, the floor is open. Any questions at all from anyone? Yeah, Harry, it is tough. If you've never seen it before, then it's quite a very quick introduction. When I teach this in, because I'm a tutor, right? When I teach this in lessons, to students, I'll normally have a full lesson just on the cosine rule. So I've done this very, very quickly, right? Just 2 questions, both very different from each other. So it's tricky to get it only one go. But hopefully you should get it when you teach us. And if you don't, then feel free to, watch this live stream again when you've done it a bit in school. It might click for you. What did you do for GCSE and grades, and what did you get? So I did a lot of GCSE. I think I did 11, 12. I don't know, as many as my school allowed. I think the main ones are separate sciences. That's what I did, and then maths. So I got an A in maths, and I got an A in all 3 sciences. I did the old spec, the AFL through C spec. So that's what I got. Thank you for asking. And then, is this on every exam board? Yes, it is. Cosine rule and the sine rules on every single exam board. GCSE and IGCSE. All of them. Every one. Yeah, it's about a grade 7. Yeah. Are you talking about A7? Is an A a 7? and technically kinda, but then again the scale was different. So like so like grade, because an A star, because to get an A star was like you had to get 90% of the paper to get an A star when I was at school. Like 90%, like that's unreal, right? Like if you make like a couple of like silly mistakes, like I used to make a lot of silly mistakes. You make silly mistakes in your paper, A star gone, poof, can't get it. So it was really, really challenging to get an A star when I was at school. But now they've made the papers harder, but they've slid the scale down. So now you only need like I think you need like 70% to get a 9 now. Maybe a bit higher, maybe 75. But you don't need as much to get a 9 as you needed to get like an A star when I was at school. Anyway, A level, I did chemistry, physics, and maths. I got ABC. So I got A in maths, B in chemistry, C in physics. Then I did my degree. Did a degree in engineering, well, material science engineering. I got a first in that. It was fun. I enjoyed it. It was a good degree. If colleges require you to have a 6 in maths, what do you do if you're doing foundation? So that's tough because if they require, you can't get a 6 on foundation. So I would talk to your school. If your school has wiggle room and they can, if you like, say if you do really well in the November mocks, could you move up to higher paper, right? Because some schools will allow that. If you do really, really well in the mocks, if you get a grade 5 in the mocks, they'll move you up to higher paper, because you need to be on higher paper to get a 6. You can't do it any other way. Or you can resit next year, but the school won't pay for it. You would have to pay for it yourself to resit the higher paper, and then get a 6 then. But then your college have to be like, the college have to then allow you to do that, because you'd want to obviously be at college while you did it. So that's that. Does that make sense? So you want to either, in theory, you need to be on the higher paper if you want to get a 6. But for that, you need to kind of prove to your teacher that you're capable of the higher paper, because the higher paper is really challenging. It's really tough. So it's a massive step up from the foundation paper. So I would make sure you're doing really, 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 if you've got the foundation paper set and done, it's easy, then the high paper, you should be able to move up. But obviously, talk to your school. Every school is sometimes different. How did you manage everything in your A-levels? Like, how did you revise? I had a tricky A-level time. I was like homeless for a portion of my A-levels, so I didn't like do very well, and I didn't do as well as I could, and my school was a bit of a mess. Hence, I think I said earlier that I resat all of my AS levels. I only did one, luckily. I did maths, but I got like a D in my first maths, so I had to reset it and get an A in my second year. So it was quite a lot. I think I did like 4 full A-levels in my 4th year, which I guess is not uncommon, but it was tough. But I think it's just having an organised brain space. My degree was a lot easier. My degree was A-levels are really, really, really hard, right? A-levels was the hardest thing I think I've ever done. My degree was undoubtedly 1,000 times easier than my A-levels. Even the 3rd year of my degree, I would have done 3 degrees at once before I did A-levels again. A-levels were really, really, really hard. Really, really hard. My degree was so much easier. So much easier. And unfathomably easier. It was so easy compared to A-levels. So I think it's just the case of seeking help when you need it, which I often didn't do, and having a good routine. If you get into a good routine when you're doing your GCSEs, it's much easier than to transition doing your A-levels, because if you kind of flew by a GCSE just without kind of trying hard, like I kind of did. I didn't really have to revise maths to get an A in it, and I did pretty well naturally. Then I got to A-level, and I didn't know what study revision techniques worked for me. I didn't know what timetable worked for me. I didn't know nothing, right? So I had to then figure it all out in my A-levels, as well as then doing so much other stuff all at the same time. So if you figure all that stuff out now, you do GCSEs, it'll make your A-levels much easier, I'd imagine. What degree did you do? I did a material science and engineering degree. So I combined all the sciences with the engineering aspect. So why materials are used for certain applications, and then how to test materials, like engineering testing, like fatigue testing, crack testing, when things are gonna break, things like that. That's what I did. It was really interesting, actually. It was really good. you suggest we go for A-levels? I mean, if you want to do a degree, there's not many alternatives, which is kind of the drawback to this country. I don't know much about the IB specification. I think International Baccalaureate, I think, might be a bit better. From what I've heard about it, I like the International Baccalaureate a bit more. But I think if you want to do a degree, A-levels are kind of your only option, you know? I don't know much about any others because T-levels are still so new, aren't they? T-levels are really, really new. So I don't know much about them yet. And then B-Techs, not many universities accept B-Techs. So, but if you don't want to go to uni, then maybe B-Techs will be better. And my partner did B-Techs and he loved them. So maybe it'll be easier. What am I doing right now? I'm going way over. I know my tutor's going to get upset with me. But I haven't got anything to do this hour, so I'm kind of just enjoying the chat that I'm having. What am I doing right now? I'm just vibing, essentially. I finished my degree last year, and now I'm just full-time tutoring. I think I'm going to go back to do another degree. Because I really enjoyed it. I love my degree. I think I'm going to do a nuclear engineering degree because I'm really into nuclear energy right now. I don't know why, but I'm feeling fixated. So nuclear engineering is like not only the nuclear, like how we get energy from nuclear, what it is, how it works, all that stuff, but also building the plants, which obviously my background in material engineering is really good for because I know what materials are useful and all that good stuff. So that's what I think I'm going to go on to do. But yeah, it's a very exciting time. So I don't really know what I'm going to do yet, but I think that's the plan thus far. I'm going to chill, do some tutoring, which I love. I love my job. My job's the best job in the world. I love what I do. And then do a degree and then just come right back to this, doing tutoring. Yeah, fun. Grand. Well, any more questions? If I should start wrapping up, people are going to get bored of me nattering away. I know, considerably dropped viewers, but I'm quite enjoying the little natter. So any other questions? If not, I'll start wrapping up. We can go about our days. Would you just taking a gap year? It depends on what's good for you, right? I knew many people at uni that had taken a gap year and they struggled for a little bit and then bounced straight back again. Like it didn't really matter to them. And then some people that didn't take a gap year, but then should have taken a gap year. Like they were very stressed at A-level and then were considerably more stressed at degree because I didn't take a break. But I just wanted to get out. I moved from Yorkshire, like the sticks of Yorkshire, to London for my degree, which was so much better in every way. I wanted to get out of my hometown. I wanted to leave, go as far away as humanly possible. After the horrible show of A-levels I just had, I wanted to run away as fast as I could. So I didn't ever consider doing a gap year or anything like that. But technically I'm kind of taking one now, I suppose, between my master's degree and my regular degree. It's going quite well. If you think you'd benefit from a break and you're not just kind of vegetate on the sofa for a year, then if you're going to take an active break, then maybe a good thing. But if you I don't know, want to get your career started and you're really interested in your course and you're really interested in uni life and you want to embrace it and go at it full force, then don't take one. It's all up to you. It's all personal preference, I suppose. I went to Queen Mary, University of London. I went to QM, which is really good. It's in East London, which is Zone 2, but not like as expensive as some of the other London unis, because a lot of the other ones are in Zone 1, which is so expensive. I can never afford a place in Zone 1, but Queen Mary's in Zone 2, which is still like really, really close to the centre, but a lot cheaper than Zone 1. So I'm really happy with QM. I really, really, really liked it. And I would still be there now if their master's degree weren't so expensive. I would still be there. So I had to come back home where the rent is a lot cheaper in the sticks of Yorkshire. But there we are. This grade, so this cosine rule was about grade 7. This question was at 7.5. Kind of roughly in the middle, in 7 and 8. It's tough. It's a tough question. It'd be like, right, kind of, whoop. Ignore that. Because I've been logged on for so long, doesn't like it. Thinks I'm stagnant. But anyway, cool then. So we'll wrap up there. I've already gone 15 minutes over. My cue's going to be yelling at me. I don't know why. I don't know. They won't be. But I'm going to wrap up now. Any remaining questions before I wrap up? That's all right, Keela. I've enjoyed this. I've had a lovely natter. I've had a lot of fun. Thank you all for joining me today. If you do want to watch any of these live streams again, if you want to watch any of the other ones we've done, then feel free to watch them over. They're all on YouTube under the X streams, all streams tab. I will be live again next week. If anyone wishes to join, we're going to do scatter graphs and pie charts, which are quite fun. Might spruce in a little bit of like how to analyze graphs, how to think critically about graphs, all that good stuff. I think it's quite interesting. Like using real life graphs as a really good like COVID one, where they're trying to be slick with the government back when COVID was first announced. I think it was quite interesting. But anyway, so I'll let you all go. Thank you all for your time. I'm going to switch to the ending screen, so I'll be here for like 5 extra minutes if you want to like chat or anything, any extra. But thank you all, and I will see you all next week. So have a lovely evening, you all. Bye.